We have been factoring trinomials by the trial and error process. However, there are a few trinomials that will fit a special pattern called a perfect square trinomial that if you notice this pattern, it might save you a little bit of time in your trial and error process. Knowing the pattern of a perfect square trinomial will also be helpful later on when we study a process called completing the square. So let's take a look at perfect square trinomials. Here's the pattern. The general trinomial looks like a squared plus 2ab plus b squared. Now, how am I going to recognize that something is a perfect square trinomial? Well, first of all, we're going to observe the first term is a perfect square and the last term is a perfect square. That's the first thing that catches your attention when you notice a perfect square trinomial. Now, if the first and last terms are perfect squares, then we're going to test the composition of the middle term. Notice the square root of a squared is a, and the square root of b squared is b. So if my middle term can be composed as the product of twice a times b, then it's a perfect square trinomial. The way that we factor it is using two matching binomials, a plus b times a plus b, which we could condense with exponential notation as a plus b quantity squared. Now, the next pattern for our perfect square trinomial is very similar. The only difference is this leading sign right here. So how do you recognize this pattern? Again, the first thing you notice is your first term is a perfect square and your last term is a perfect square. If you notice that, then you can also test the composition of your middle term. If it is twice the product of the square root of the first term times the square root of the second term, 2ab, then you're dealing with a perfect square trinomial. So this one factors as a minus b times a minus b, which we could condense as a minus b quantity squared. Now, if you're working with a trinomial and you don't notice that it's a perfect square trinomial, you can still factor it by trial and error and get the right answer. But let's practice applying these patterns on example 6. Factor the following perfect square trinomials. So here we're given a good clue. These are going to fit the pattern. But how do you recognize it in just a random group of examples? So we have 4x squared plus 4x plus 1. The first thing that I notice is my first term is a perfect square, and I'm just going to observe the square root of that term is 2x. I also notice my second term is a perfect square, and the square root of that term is 1. So it's looking like a perfect square trinomial, but we got to make sure our middle term has the right composition. So I'm going to double the product of the square root of the first term and the square root of the second term, which we found down here. And notice that gives me the correct middle term, 4x. So we can confidently say this is a perfect square trinomial as was stated. So we're going to factor it as two matching binomials where the first term is that square root of the first term that we noticed over here. The second term is the square root that we noticed over here. Now, again, notice back in our formulas, if my leading term is positive here, then my two signs are going to be positive. If my leading term is negative, my two signs are going to be negative. And notice that one is always positive for a perfect square trinomial. So the two signs that we're going to use here are plus and plus. So the factorization is 2x plus 1 times 2x plus 1. Again, you could figure out those binomial factors with the trial and error process. Let's go ahead and write this in the more condensed form, 2x plus 1 quantity squared. Now, to check my answer, I'm going to go back to the expansion of my two binomials, and I'm going to FOIL. So multiplying our first two terms together, 2x times 2x gives us 4x squared. Outside terms have a product of 2x. Inside terms have the same product. That's always going to be true with a perfect square trinomial. And the product of our last terms is 1. Combining our two middle terms, we have 4x squared plus 4x plus 1. That matches our original problem, so we know that our factorization is correct. Okay, let's try another one. We have 9x squared minus 30x plus 25. Again, the more you factor, the more sensitive you'll become to these patterns. I'm going to notice, hey, that one's a perfect square, and I'm just going to observe its square root is 3x. This one's a perfect square. Its square root is 5. So it's looking like it could be a perfect square trinomial, but it'll only fit the pattern if our middle term works as well. We want to know, is the middle term twice the product of the square root of the first term times the square root of the second term? 2 times 3x times 5 does give us that middle term, 30x. So this is definitely a perfect square trinomial. So our factors are going to be two matching binomials. The sign in each binomial is going to match this sign. So I'm going to pick up the square root that we discovered over here, 3x. The sign is minus. I'm going to pick up the square root here, which we discovered, 5. And my second term, or my second factor, matches. In the more condensed fashion, we can call that 3x minus 5 quantity squared. But don't be done yet. Remember, we want to be diligent and check our answer. So I'm going to look at my expanded binomials here in FOIL. 3x times 3x is 9x squared. Our outside terms have a product of minus 15x. Our inside terms, again, notice it's the same product. And last, negative 5 times negative 5 is positive 25. Combining our middle terms here, we have 9x squared minus 30x plus 25. And that matches our original problem exactly. So we know we have factored our perfect square trinomial exactly. It's good to be familiar with this pattern, again, because we'll use it later on in a process called completing the square.